Alright, we're going to have a little video on line drawings. So essentially starting from the point of a Lewis dot diagram, if we were to take carbon and hydrogen, we know that carbon's got 4 valence electrons, and we know that hydrogen has 1 valence electron. And if we were to create a Lewis dot diagram, this would be it. So we would have carbon with the 4 electrons surrounding it, the valence electrons. Hydrogen would have the 1 electron each, and essentially carbon and hydrogen would share electrons. So we'd have a covalent bond here, a covalent bond here, covalent bond here, covalent bond here, and so this is a representation of where the electrons are. Covalent sharing between the carbon and the hydrogen. So another way to represent this is, instead of drawing the 2 dots, is we actually just draw a line. And it just makes it easier for us to represent the electrons. So again, these straight line right here is actually the same thing as this covalent representation of 2 sharing of electrons here. So this line is exactly the same, and this is typically called a line drawing or a skeletal drawing. I always refer to it as line drawing because it has lines in it. So where this really starts to come in handy is when we have a larger molecule. So let's say I've got something like hexane. Hexane's got 6 carbons. 1, 2, 3, 4, 5, 6. If I want to draw a Lewis dot structure of that, then I've got 4 electrons around each. And you can time me on how long this actually takes. Hopefully I've got all the electrons in here. And then now we need a hydrogen on each one of these. Forgot hydrogen. See, forgot the electron for the hydrogen there. Hopefully I've got all the rest. And if I wanted to, I could draw little circles around everything representing where all the covalent bonds are. Could actually help me check and make sure everything is correct. So as in the previous thing, what I can do is actually now instead just draw lines between them. I count up the number of carbons: 1, 2, 3, 4, 5, 6. And I can represent all the hydrogens on here as well with the line. But as you can see, this still takes some time to do. And what I'm going to show you is that there's an actual even easier way to do this, and I'll show you on the next slide. So I want to draw hexane, but I'd like to actually short form it even more. So what we're going to do is we're going to start with 1 line, and this is a carbon-carbon bond, another line, another line, another line, another line, and if we're to add these up, I've got 1, 2, 3, 4, 5, 6 different points essentially here, and what we're going to do is start to define what this means. Each one of these little spots here, so this apex essentially, is a carbon. So in the previous thing, we actually drew out the carbon specifically. But what we're going to do is we're not going to draw the carbons and hydrogens anymore. There's going to be a number of things that are going to be implied in this. The first off is that at each point here, this is a carbon. So that's the first thing. The next thing that we're going to go through is at each one of these carbons, if there's nothing drawn on it, that carbon has a fulfilled octet. Each one of these has a fulfilled octet, and in order to have a fulfilled octet, it needs to have 8 electrons around it. So this line right here represents a covalent bond between a carbon and another carbon, even though I don't draw it. So if I were to draw it down here, here's a covalent bond between this carbon and this carbon. So this is this carbon, this is this carbon. So here, this carbon right here, this one, I've only showed 2 electrons sitting here in this covalent bond to the carbon. What's implied is that in order to fulfill the octet, is all the rest of the electrons are coming from hydrogens that we do not have to draw. So it's implied that this actually has 3 hydrogens on it. So for this carbon, the second one, this carbon has 2 covalent bonds that are spoken for. 2 electrons from this carbon, 2 electrons from this carbon. It needs 4 more electrons, so it will have 2 hydrogens sharing 2 electrons. So I've now got on this carbon 2, 4, 6, 8 electrons around it, so this octet is fulfilled. The hydrogens octet is fulfilled. But notice that I did not actually draw in the hydrogens here. I knew that this carbon had 1 carbon attached, a second carbon attached, and therefore it had to have 2 hydrogens hanging off. The same goes for this one. There's going to be 2 hydrogens implied, 2 hydrogens implied, 2 hydrogens implied, and for the last one there's going to be 3 hydrogens implied. So to redraw that again, I would just do this, 2, 3, 4, 5, 6, and that's it. This is hexane. If I could actually write it out. So this is hexane, and again, each one of these apexes here represents, or vertice represents, a carbon, and it's implied that each of the carbons fulfills the octet. And in order to fulfill the octet, if there's no other atoms attached to it, it's implied that they are hydrogens that are allowing it to fulfill the octet. So let's take, for example, ethanol. So we've got actually, let me start right from the Lewis structure. So I got a carbon, all right. All right. So each one of these has the octet fulfilled. So the carbon's octets are fulfilled. The oxygen's octet is fulfilled, and the hydrogen's octets are fulfilled. Also notice that on the oxygen there are 2 lone pairs. So another way to draw this as a line and so each one of these lines here in between an atom represents 2 electrons and a covalent bond, as we implied before. Whoops, I got a little bit of extra going on here with the oxygen. So let's make sure we get this right. And I'll show the lone pairs here as well. But now if we were to do line drawing, essentially all I need to do is show the 1 carbon bond to the next carbon, oxygen, and the H, and that's it. So this is the Lewis dot diagram. This essentially is a more basic sort of line drawing. They also call it a Lewis dot diagram as well because of the structure of it. And then this is called a line or a skeletal drawing. Again, what's implied at the end of each of these apexes here, this is a carbon, so these carbons are the same. The oxygen is represented up here as well. And one thing to notice is that the lone pairs of electrons are actually not drawn on. They don't have to be. So I can draw them in, but in a bunch of cases you will find that the lone pairs are not drawn in. And what that means then is that you're going to have to be careful taking a look at these. Remember that everything is supposed to have a fulfilled octet. So in order for carbon to have a fulfilled octet, there is 1 bond to it, 2, 3, 4 bonds. Each one of these has an implied hydrogen. This carbon has a fulfilled octet. 1, 2, 3, 4 bonds. That's 8 electrons surrounding this carbon, a fulfilled octet. This oxygen. So the oxygen has 2 electrons, 2 electrons. It only has 4 electrons. Since no other atoms are attached, that means that we've got 2 lone pairs attached to it as well. And that's implied. We do like to draw them out there, but a bunch of drawing programs that are used for textbooks and people on the internet, these a lot of times are not actually shown. Oops, I got rid of my entire oxygen. So just make sure that you know that that's implied in there. So again, just to show the nice clean structure, it won't let me draw the O. There we go. That's ethanol. So what this allows us to do then is to draw more complicated molecules much more easily. So if I were to have a compound that had essentially 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 carbons, and I could have groups hanging off of it, and it just allows for a much easier way of drawing a compound with all sorts of different types of groups on it and different arrangements of atoms. To draw the Lewis structure of this would be, well, maybe about a half hour or something of your time. And this is the type of structures that we're going to start getting into and learning how to name and do reactions of.